Hello everyone. We are going to talk about exponents today. This is lesson 1.1 on our exponents unit, and we're going to just start with some vocabulary. So I know you've all seen exponents before, but we're going to start at the beginning. So this number, the number that's the regular, oops, the number that is printed in the regular size is called the base, and the little number up above it is called the exponent. And the whole thing together is called a power. And when we write a number like this, we call it exponential notation. So that's actually all you need to do the vocab sheet. There's 2 pages of vocabulary, and all you're doing is using these words, okay? And that's it. Well, I'm going to do the exponential notation lesson 2 because it's really quick, and then you can go do both of the assignments. Actually, that's probably better looking at the assignment now. Better to do all of these notes first. Okay, what is exponential notation? Well, let's back up a bit. What is multiplication? Well, multiplication is actually just an efficient way of expressing repeated addition. For example, instead of writing 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5, we write 5 times 8 because there are 8 of them. So we're adding up 8 fives. And because this is something we use all the time, this is one of our number facts, we should theoretically memorize the fact that 5 times 8 equals 40. And that's definitely in the times tables that you should know. Exponential notation is just an efficient way of expressing repeated multiplication. For example, instead of writing 5 times 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 5, we write 5 to the power of 8. Note, however, there's 2 big differences between the multiplying and exponents. With multiplication, the order doesn't matter. 8 times 5 is also 40. But with exponents, the order does matter. 5 times 8 equals 5 times itself 8 times, and 8 times 5 is 8 times 8 times 8 times 8 times 8, 5 of them. So I'm going to go back up here to our vocab and just expand a little bit on what we've written up here. So the base is the number you are multiplying. And maybe we'll even add the number you're multiplying by itself. And the exponent is how many times you are multiplying the base by itself. Okay, so 2 to the 5 means 2 times 2 times 2 times 2 times 2, 5 times. 1, 2, 3, 4, 5. Okay. Okay, let's go back down here. The other difference between exponential notation and multiplication is, well, what the one really, really important one is that the order does matter. And the other one is that nobody expects you to memorize 5 to the power of 8 or 8 to the power of 5 because those are just massive numbers and nobody expects you to know that. There are some that you are expected to know, and I will show you those in just a minute. I just want to go through this reading of exponential notation first. 9 times 9, we write as 9 with a little 2, and we read this out loud as 9 squared or 9 to the power of 2, but when there's a 2, we do say squared, and that equals 81. 7 times 7 times 7 is 7 cubed. Oh, and right, there's a typo here I need to fix. This is 7 cubed. Or 7 to the power of 3, or 7 to the third power. 2 to the 5, 2 to the fifth power, 2 to the power of 5, 2 to the 5, and it means 2 times 2 times 2 times 2 times 2. 10 times 10 times 10 times 10 is 10 to the 4, or 10 to the fourth power. I should actually write this in, or 10 to the 4, that's the shorthand. Okay. So we don't have a special, we have squared for 2 and cubed for 3, but we don't have special names for any of the higher powers. Any number higher than that we don't have. Just one little wrinkle in how things are named. If you ask for something to be written as a power of 7, it means you would write it as 7 to the something, okay? Which I realize is backwards because we kind of use the same terminology up here. I don't know why it is that way, but it is that way, so just be aware of it. Yeah, I don't know why we do that, but we do. The other thing is, although we call these powers, we call the whole thing is a power, we don't properly, we should probably say this is 2 to exponent 5, but I've only ever heard one person in my life say that. Everybody else says 2 to the power of 5. So that's just the way the world works sometimes. Okay. All right. I said I would show you which exponents you are expected to know. So let's pop over to the toolkit. And this is the page we did with the squares and square roots. And there are, I said I would give you more numbers on here, so that's what I'm going to do now. So I want you to write down, here's our x. This is going to be our x cubed, and we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to write them all in, and then I'll tell you which ones you need to know. Okay. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Okay, you should know all of these. Oops. Know these. And you should also know that 10 cubed is 1,000. The other numbers that go in here are 216, 343, 512, 729. And these ones, you should recognize these. You should see the number 343 and go, oh, right, that's a power of something. Okay, and you might need to think to figure out what it is, but you should know that it's a power of something. Okay. All right, and then down here, oh, the other thing that I will add is that if this column is y, then this one is the cube root of y. Okay, because cubing something and taking the cube root of something, those are inverse operations. One does, the other undoes. All right, we also need to know some x to the 4s. So we're 1, 2, 3, 4, and 1, 16, 81, and 256. You should, I'll do this in red again, you should know these. and you should recognize this one. And again, if this is the y, this is the fourth root of y. And here we have x and x to the fifth, 1, 2, 3, 132, 243. You need to know these ones and recognize this one. And if this is y, this is the fifth root of y. Okay? Anytime I ask you something with a fifth, something to the fifth power, it grows so fast that it's almost always going to be one of these three. Just to pop that into your memory. All right, that is it for this lesson. Go ahead and do the practice work. Make sure you check your answers because there are some, actually, let me just go to the homework assignment because there's one that I know you're probably all going to get wrong if I don't show you this because we didn't cover this yet. In this one, the base, the exponent is always the little number. So in this case, it's -5. And the base is going to be, if there's brackets here, it's everything that's in brackets. Okay. And then for this one down here, if the base is like that, if it's something other than just a single number, you must put it in brackets. So this is -7/4 to the 6. And this one is going to be -6.1 to the 0. Because that's not the same thing as -6.1 to the 0. Those are not the same. Okay, this is the correct one here for this base. Okay, we'll go into that a bit more on tomorrow's lesson, or the next lesson. But this is just about practicing what's the base, what's the exponent, and what does it look like when you put it together. That's all this is. Okay, and there's 2 pages of that, and then this table. You're just changing things from exponential form to expanded form, and then value, which is what does it equal. So for here, we've got 4 cubed, which is 4 times 4 times 4. And from my table, I know that 4 cubed is 64, and that's one that you should know or be working on learning. There's some in here that you don't, like there's one down here, 31 squared. I don't expect you to know that. Most of the other ones you should, the rest of them are ones that you should have. They're in the category of you should memorize these, I think. Not the 6 cubed, but okay, that's it. Go and have a great day. See you later. Bye.